So welcome to YouTube channel Electronics for You. Friends, in this video I will explain parallel circuit of resistances. So in my previous videos I had explained series circuit of resistances. Now we are continuing the second part, that is parallel resistances. Now here you can see that these three resistances R1, R2 and R3, they are connected in parallel. Basically parallel, when we say they are connected in parallel, they are having single common two common point. Here you can see that this is one common point and this is another common point, and to these common points, generally we call this common point as nodes. So there are two nodes in the parallel circuit and these resistances are connected here to these 2 points, and here you can see that the voltage supply V is applied here, the current I is flowing, and three resistances are connected in parallel. Now same circuit can be drawn just like this. Here you can see that this is our A and this is our B node. This circuit and this circuit basically is same, only we have changed this like this. Okay, now let us talk about one different parameters such as current, voltage and resistances one by one, just like the series circuit. Now voltage in parallel circuit. So this is our parallel circuit. In this case you can see here that this voltage supply is applied to point A as well as point B, and as this voltage supply is connected to these two nodes and every resistance is connected across these two nodes, therefore the voltage will remain same for all resistances. It means that voltage across resistance R1, voltage across resistance R2 and voltage across resistance R3, all these will be equal, and again this will be same as that of the battery supply. So it means that in parallel circuit voltage remains constant across these two nodes, that is V is equals to V1 equal to V2 equal to V3, where V1, V2, V3 are the voltages across R1, R2 and R3 respectively. Now let us talk about the second parameter, that is resistances. So in when resistances are connected in parallel like this, they are connected, they are having here the common points, and so now these three resistances can be replaced by a single resistance, that is called as equivalent resistance or total resistance, and here R equivalent is equals to parallel combination of this. Now in parallel combination, generally 1 upon R equivalent is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. If more resistances are connected, definitely their reciprocals will be added. Therefore we can say that in case of parallel resistances, the equivalent reciprocal of equivalent resistance is equals to sum of reciprocals of individual resistances connected in parallel. Now let us talk about third parameter, which is current, and which is very important. Now this is our current I in the circuit. Okay, now here you can see that this current I will get divided here because it is just like the pipelines. Okay, so one pipeline is further connected to three different pipelines, so the water supply will be affected and it will be get divided into three pipelines. Similarly here also the current is divided into three different branches. Here I1, I2 and I3 are the current flowing through R1, R2 and R3 respectively, and therefore in this case we know that equivalent resistance 1 upon R equivalent is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Okay, so here by Ohm's law you can calculate the current here. I is equals to V upon R, but R is here the total resistance, which is nothing but R equivalent. So we can say that this is I is equals to V upon R equivalent in this case. So here we can calculate the individual currents by using Ohm's law again, that is I1, I2 and I3 respectively. Here I1 will be equal to V, that is voltage supply, divided by resistance R1. Similarly, I2 is equals to V divided by R2 and I3 is equals to V divided by I3. Now, if you will add these three currents I1, I2, I3, we will get V divided by R1 plus V over R2 plus V upon R3. So further this V can be common here and the equation will look like this, and this 1 upon R1 plus 1 upon R2 plus 1 upon R3 is nothing but R equivalent. So here is our equation. Further, V upon R equivalent, this is nothing but the total current. Okay, so it can be replaced by I, and therefore we can conclude here that the total current is equals to sum of individual currents. Similarly, this is nothing but the KCL, that is Kirchhoff's current law. Here in this case, at node B, at node A, I was incoming current, whereas I1, I2 and I3 were outgoing current. So sum of incoming current is equals to sum of outgoing current, that is I is equals to I1 plus I2 plus I3. Thus KCL is also proved in case of parallel circuit. So here let's have a summary about this. Voltage will remain constant across every resistor, then current will be equals to sum of individual currents flowing through the branches in parallel circuit, and resistance will be equal to, that is total resistance is equal, reciprocal of total resistance is equal to sum of reciprocals of individual resistances. This is the conclusion. And again, this total resistance is always smaller than the resistance of the individual resistors connected in parallel. It may be smaller than, or sometimes it may be equal if same values of resistances are there. Okay, so in next video I will solve some problems of simple parallel circuit which are having resistances. So friends, if you like this video, keep watching. Please share this video with your friends and subscribe our channel. Thank you.